Je déclare la séance ouverte.
I'd like to call the meeting to order. Welcome to meeting 34 of the Standing Committee on Science and Research. Today's meeting is being conducted in a hybrid format in accordance with the House Order adopted on June 23, 2022. Therefore, members can participate in person or remotely using the Zoom app. Today, we're continuing our study on support for the commercialization of intellectual property. To ensure that the meeting runs smoothly, I'd like to pass on some information to witnesses and members. Before you speak, please wait for me to call your name. If you're participating via video conference, click on the microphone icon to activate your microphone. Please mute yourself when you're not speaking. As far as interpretation is concerned, for those on Zoom, you have a choice at the bottom of your screen between floor, English, or French. For those of you in the room, you can use the earpiece and to choose the desired channel. I'd like to remind you that all comments from members and witnesses should be directed through the chair. For members in the room, if you wish to speak, please raise your hand. For members on Zoom, please use the raise your hand function. The clerk of the committee and I will do our best to keep the order of speaking, and we thank you for your patience and understanding in this regard. In accordance with our housekeeping motion, I would like to inform the committee that all witnesses have completed the required login tests prior to the meeting. I'd now like to welcome our witnesses. We'll start, first of all, with Gail Murphy, Vice President from the University of British Columbia, Vice President of Research and Innovation, as well as William Galley, Vice President Research from the University of Calgary. We'll start with your opening remarks. You'll each have 5 minutes. And we'll start with Professor Murphy. Please proceed. You have the floor.
Thank you, Mr. Chair, and thank you for inviting me to join you today. As you've heard, I'm Gail Murphy, Vice President, Research and Innovation at the University of British Columbia. I'm also a professor of computer science and a founder of Tasktop Technologies, a 200-person software company recently acquired by PlanView. I'm joining you today from the traditional, ancestral, and unceded territories of the Musqueam people. For centuries, a place of learning and discovery. UBC is the second largest research university in Canada, with nearly 70,000 students and more than 17,000 faculty and staff at campuses in Vancouver and Kelowna and sites throughout British Columbia. UBC is consistently ranked amongst the top 50 in the world and attracts over $700 million in research funding each year. UBC researchers are responsible for tremendous contributions in new technologies, life sciences, the environment, clean energy, public policy, and economic growth. UBC also ranked first in the world in the category of industry, innovation, and infrastructure in the 2022 Times Higher Ed Impact Rankings, and has the highest number of active licenses from intellectual property developed from research in Canada. Research universities produce IP in many different forms, including patents, copyrights, and trademarks. Different research universities approach IP differently. At UBC, we have an institution-owned model where researchers disclose inventions that are proprietary in nature to the university. The university then works with those researchers to find a way to mobilize the IP, taking into account personal preferences, the field of research, and the economic sector. Generally, IP mobilization happens through licensing, spin-off companies, or knowledge exchange. At UBC, we successfully and continually deploy IP through each of these mechanisms. BC's thriving biotech sector, as one example, is in large part based on our research mobilization success, such as the UBC spin-off company AbCellera, which currently has a market cap of over $2 billion and more than 500 employees. And to give a sense of scale, last year UBC filed 353 patents, had 622 active technology licenses, and undertook approximately 1,400 sponsored research projects, most with industrial partners. UBC is also exploring new forms of partnerships, particularly with large Canadian companies, creating more open-ended research collaborations to solve industrial challenges. As one example, a 5G partnership with Rogers has enabled projects in wildfire management, as well as in telemedicine, to be able to reach patients in remote and rural communities. While we have seen success in generating and mobilizing IP, Canada can build on this by investing in 4 areas: people, partnership, pilot funding, and patenting. First, there's an urgent need for further investment in graduate students, as they are absolutely critical to moving inventions and ideas from the university into startups and Canadian companies. This was certainly true for the company I co-founded in Canada. In Canada, we lag in the production of graduate students and are simply not funding those graduate students at internationally competitive levels. We are at significant risk of losing talented young people to other jurisdictions. To attract and produce more graduate students, the federal government needs to increase both scholarship and tri-agency funding for research, most of which goes towards graduate students. Secondly, we need to better and more completely support partnerships. While many helpful programs exist, gaps do remain. And one of the key gaps is support for institutions to cultivate, develop, and sustain partnerships, such as the one between UBC and Rogers I noted earlier. A third opportunity is to fund the scaling up of proof of concept research results into pilot technologies that are appropriate for spin-offs and investor funding. Taking, for example, promising new chemical or biological processes from a test tube to something closer in scale to commercial production. A final opportunity area is to increase support for patent writing and filing at universities. While Canadian research universities are very well known for their ability to discover and to invent, we are limited in our ability to protect IP through patents due to a lack of funding. I have had the opportunity to bring research results from software engineering, my research area, to the market, and this was simply one of the most rewarding parts of my career, to see our ideas really impact the business of software development. Collaboration between academia and the private sector is growing exponentially, but we need to move from a stream of ad hoc initiatives to a focused national imperative that properly and purposefully supports this work for a more resilient economy and thriving society. Thank you for this opportunity, and I look forward to your questions.
Merci, Professor Murphy. Je cède...
Thank you, Professor Murphy. We'll now go to Mr. Galley. You have 5 minutes.
Thank you, Mr. Chair. Merci, j'apprécie beaucoup cette...
Thank you very much. I greatly appreciate this opportunity to speak to the Parliamentary Committee today.
William Galley, Vice President Research at the University of Calgary. I'm joining you today from the traditional territories of the Treaty 7 First Nations of Southern Alberta. Calgary is also home to Métis Nation of Alberta Region 3. Like Dr. Murphy before me, I'm a stakeholder from a Canadian post-secondary institution. More specifically, I'm a Vice President for Research, a role that not only oversees research, but also my university's innovation ecosystem. The backdrop of Canadian innovation and commercialization, unfortunately, isn't great. While Canada scores in the top 10 countries for basic research by various traditional measures, the impact of our innovations assessed by metrics such as patents, licenses, and company creation is modest. Our post-secondary sector presents a paradox. Data show that our universities are sought after internationally because of the strong reputation of our educational programs. Our post-secondary research is also very strong, and we achieve internationally leading levels of per capita scientific publication and citation. Yet despite this, Canada lags in those previously mentioned innovation metrics. Why is this? One challenge may be the sometimes competing missions of universities. Our provincially funded universities exist, after all, to deliver educational programs. We also need to retain our professoriate and uphold campus research infrastructure, laboratories, IT systems, and so on. In the face of budget pressures, and universities in several provinces have faced that, something has to give. In such situations, innovation expenditures are sometimes seen to be a luxury, nice to have, but not necessarily must-haves. Clearly, there needs to be a change of mindset. Knowledge economies in their fullest form are fueled by research universities, if and only if the research in those universities is mobilized toward innovation. At the University of Calgary, we have activated a number of programs that attempt to demystify and enable commercialization pathways. We have a Hunter Hub for entrepreneurial thinking that does exactly what its name suggests, campus-wide. We have an exciting cohort program called E2I, Evolve to Innovate, that exposes large cohorts to group innovation training, early stage exposure. We have a more intensive and personalized academic entrepreneurs in residence program that provides longitudinal mentorship to selected teams by experienced research entrepreneurs. We also have a set of USEED funds, evergreening venture funds established through philanthropy. Is it all working? Well, maybe yes. UCalgary has been #1 in Canada in startup company creation from the university for each of the last 2 years, according to AUTM, with about 20 new companies created annually. Many of these companies have gone on to achieve maturity and growth, create jobs, and attract capital. I know this is a parliamentary committee and that questions of science policy are paramount here. I do think that there is an important federal government role here. Several federal government programs are noteworthy. These include Prairies Can investments in my region and ISED's new Elevate IP program, for which UCalgary will be one of the hubs. I'm also optimistic about the Lab to Market program announced in Budget 2022. I look forward to hearing specifics of that program. I also, of course, want to see the details of the new Canada Innovation Corporation, from which I hope there will be strong program connections with Canada's post-secondary sector. In closing, I'll point to Singapore and Switzerland, two quintessential knowledge economies. In both, federal government funding plays a major role. In Singapore, the two major universities, NUS and NTU, have impressive tech transfer systems fueled by substantial government investments. And in Switzerland, it's the two federally funded R&D institutions, EPFL and ETH, that shine particularly brightly as innovation exemplars internationally. I am optimistic about some of the trends I see, both nationally and, of course, at my institution. And I'm hopeful that this committee and the federal government will continue to explore ways to advance Canada's knowledge economy. Thank you for your attention. Merci pour cette opportunité.
Thank you for this opportunity. Thank you, Dr. Galley. We'll now go to the first 6-minute round of questions. We'll start with Mr. Williams.
Merci beaucoup.
Thank you very much, Mr. Chair.
Thank you for our witnesses for joining us today. This is a fascinating study, and we're happy to have you both here. IP commercialization in Canada universities is often referred to as the great term, the valley of death. So I'm wondering if each of you perhaps could just comment on where did this valley of death come from? Why do we have such a tough time commercializing IP from our universities? Professor Murphy, if you want to go first, then Dr. Galley.
Yeah, thank you very much. I think sometimes we overstate what you've termed the valley of death. I think we have many examples of where we are successfully moving new ideas, commercialization policy out into use within our economy and our other sectors. There are places where there could be more support. Dr. Galley mentioned a few of them. There are places where we need to have more ability to work longitudinally with companies in Canada to be able to move ideas into use. For our more entrepreneurial-minded spin-off individuals, there are significant challenges, as I mentioned, in moving kind of research results from the lab into use by showing a capability of doing it at a pilot scale. There's also challenges for those companies, particularly in the current climate, for raising their initial capital. The more that you have a company that is going to be capital intensive, the more difficult it tends to be to grow in Canada, to be able to put in place the infrastructure, to be able to get your product into a commercial form. And the final thing that I would mention, sorry.
And I was just going to ask, my main question in all this is, how are you tracking this right now? So is there a way you're tracking the funding for commercialization? Do you check in with companies later? Do you track jobs? How are we tracking commercialization as a whole from universities?
So we track both of those things. As Dr. Galley mentioned, there is also an organization called Autumn that tracks licenses and patents. But we also follow up with our spin-off companies to track the amount of investment over time and the number of jobs that were created in Canada.
Okay, thank you. Dr. Galley, I know you have a spin on this. You talked about something that's really important to me, entrepreneurs in residence. Can you tell me how that program works and how are those mentors involved with helping to grow companies?
Yes, thanks for the question. So that particular program is one where where one key element is the people who are the mentors in the program. These are individuals who have generated IP through research and scholarship at the university, and they have undertaken a journey themselves of commercialization or knowledge transfer that has, in some cases, created social enterprises and social innovations, but in other cases, technology-based innovations. And those mentors have one role that relates to simply spotting IP and speaking to colleagues in a generic way about, there's a journey that could be taken, a career step that you might consider that doesn't necessarily grasp onto a specific innovation or a specific IP element of interest. They are later involved in the actual mentorship of teams that have something that they want to bring forward, and they do have an intake where they consider the concept that a group has in mind, and if that concept is mature enough, it goes into the academic entrepreneurs in residence program. If less mature, they are potentially diverted to our Evolve to Innovate program, which is a less IP focused program. It's more about mindset and pathways.
Doctor, you talked about 20 companies created annually. Is that normal for universities? Or is that something, as you're saying through Autumn, that you're excelling at, perhaps because of the Entrepreneur in Resident program?
Yeah, I think there has been a change. For us, it is an increase over prior years where there were certainly in earlier years less than 10 companies formed. I don't think doubling happens coincidentally. Of course, I'm an epidemiologist in my research, so attribution I have to be cautious with, but I think it is partially because of the Hunter Hub and the whole discourse around entrepreneurship campus-wide that has shifted mindset some. And then I think it's the suite of programs. The academic entrepreneurs intervention, I think, is particularly powerful, as you've noted in your question, but so is the USEED fund, which is an incentive, after all, to position oneself to go after money and to advance a concept. We also have our tech transfer entity, Innovate Calgary, that has had a significant enhancement in our institutional investments. So a lot of things.
So for my less than a minute left for each of you, so very brief, is there a federal policy, regulation, or piece of legislation which is hindering innovation for Canada right now? Perhaps something that the Americans, for instance, are seeing in the universities that we're not in Canada?
Dr. Murphy, do you want to, I'll let you say first, I'll think too.
I'm not aware of any particular legislation. I think it's more a mindset in Canada of making sure that we, for instance, buy from our Canadian companies that are starting out to make sure that they have an ability to generate cash flow and revenue and continue their growth.
Yeah, and I also don't have necessarily a policy or legislation that hinders, but perhaps a culture of incentivizing and potentially some tangible programs that incentivize could be science policy considerations at this committee.
Thank you.
Merci, député Williams. La parole.
Thank you, Mr. Williams. We'll now go to Ms. Bradford. You have 6 minutes.
Merci, Monsieur President.
Thank you, Mr. Chair.
My apologies for my laryngitis this morning. So I'll try and keep my questions short and hopefully your answers long. So I'll ask these questions to each of you, and maybe Dr. Murphy can start. What initiatives can be explored to strengthen links between research and conducted in post-secondary institutions and Canadian industry needs?
Well, thank you very much for the question, and I hope you feel better soon. I mentioned partnerships, and I think partnerships are very important to form between Canadian industry and academic institutions. Not only are we able to take advantage of talented groups of individuals within the university to help solve company problems, but the company also finds a source of talent to bring into their company later. So the partnerships that I'm mentioning, we tend to do at the scale of the university. The company brings a set of problems, and then we work with groups of researchers in a foundry model to be able to brainstorm different approaches to being able to forward the ideas of that company and then work collaboratively together on them. It means that we bring together multidisciplinary teams, and we're finding that new partners are coming saying, we would like a partnership model like Company X had because we're seeing results that we're really interested in from it.
Yeah, and I would just jump in and echo Dr. Murphy and say that partnership funding programs are something that I would say, speaking as N of one, but as a vice president of research, I would welcome. And I think we know that the NSERC programs, the alliance programs are very good for bridging researchers within post-secondary institutions with companies. And there's a bi-directional consideration of strategically important research initiatives and questions. In the health space, which is my own space, there used to be a program called the EHIP program, eHealth Innovation Partnerships Program, that looked for partnerships between health systems, industry, and post-secondary institutions. And those programs are at that valley of death that was mentioned in the previous line of questioning. And I think that partnership programs are a really valuable thing. There should be some fundamental science, of course, in the funding system that doesn't necessarily anchor in partnerships, but partnerships are powerful.
Thank you. What are businesses and academic institutions doing to support the commercialization of IP, and what obstacles do they face in this regard, and what are they doing to overcome them? Dr. Murphy, do you want to start?
For sure. So there's two different routes that we take in working with industry. Some of our projects are sponsored research, where the industry is providing some funding. Perhaps some funding is coming from the federal government, and then there's a project that undertakes as a result of that. My tax programs are another example of this kind of form of sponsored interaction. And in those cases, there's really more onus on the companies to figure out what the new ideas, new approaches how they might fit into their product lines, and then take it forward. Often we're building on existing IP that a company has, and we're helping to further that to the next generation. The other category we've been referring to today is really in the spin-off, getting companies directly out of university inventions. And in those cases, the universities, in many cases, as Dr. Galley was mentioning, are trying to incubate and accelerate along the pathway. We also have entrepreneurship programs, accelerator programs to try to incubate it. Where companies often face a challenge is making that jump from being within that university environment to then being on their own and starting to grow into large companies. In general, in Canada, we see great success with our startup companies. They get to a certain size, and then trying to grow into the much larger company is a challenge. And part of that is some of our industrial policy, in which there are cutoffs of sizes of companies in being able to participate in certain programs. And the more that we can smooth that, the more that perhaps we are able to grow our companies more successfully.
Yes, I think the ramping up stage is always a challenge, and that's part of the Elevate IP program is hopefully to address that. Dr. Galley?
So I have the easier job because I get to follow the wisdom of Dr. Murphy. But I do want to add one piece, and that is that both of us here are from the post-secondary sector, where as I see the numbers, Canada is actually rather strong in both public sector expenditures for R&D and in the performance of the post-secondary sector in terms of expenditures in research activity. In contrast, I see the statistics in business enterprise expenditure on R&D to be significantly lagging, and it's when the combined public sector and private sector expenditures on R&D are combined that Canada falls in the OECD ranking of per capita expenditure. Sorry, go ahead.
Okay, so Dr. Galley, I'll let you do the question first this time because it kind of builds on this. Are there areas where Canada is excelling in IP commercialization in areas where we need to support better, such as in academia or certain business sectors? You were kind of alluding to that.
Yeah. So whether there are particular sectors, so one area that I could comment on, and we've been quite active as a post-secondary sector, it has been responding to the federal government's bioinnovation and biomanufacturing strategy and the investments that have been made just recently, I think motivated by the pandemic and the realization that Canada was lacking domestic capacity to mobilize quickly for novel therapeutics, diagnostics, and most notably vaccines. I don't want to overstate the negatives because there is a biotech and bioinnovation sector in Canada, and there are investments being made now to try to bolster that through the Canada Biomedical Research Fund. However, to answer your question, that is one domain where I think the stress test of a global pandemic revealed that sector to be weaker than that of some countries. And I think we could look to what the UK achieved and what the US achieved with the rapid mobilization of massive funding for vaccine development. And indeed, the two most notable vaccines came out of
Professeur Galli, je dois vous interrompre.
Professor Galli, I need to interrupt you. The 6-minute time period is up. We'll now go to Mr. Cannings. You have 6 minutes.
Well, thank you, and it's great to have you, the two witnesses here before us today. Very interesting. Particularly happy to see UBC represented, my alma mater and where I worked for many years. And I'd like to start with Dr. Murphy. I mean, we've heard, and you mentioned some of the initiatives and innovations that came out of the pandemic. You mentioned AbCellera, my friend Peter Cullis and his work on lipid nanoparticles, and then I think Precision Nanosystems is developing those things. Just wondering if you could perhaps use those researchers and the companies that formed out of their research and where they're headed now as kind of an example of how they did it. Did they do it right? Have you learned something from that process? Because it's something that I think we should all be proud of, but one of the things we are concerned with here is keeping IP in Canada as much as possible. So perhaps you could just maybe expand on that story and say what we learned, where we're headed.
Thank you, MP Cannings, and we are proud to have you as an alumnus of UBC. So let me briefly recap two stories that are related to the biomanufacturing and life sciences sectors. One is the company I mentioned earlier, AbCellera, started by Carl Hansen at UBC for antibody therapies. An interesting aspect of Carl's work is he incubated the technology at UBC for an extended period of time as he built AbCellera. And it was a real case of where Canada Foundation for Innovation Infrastructure was used for both research and for innovation. And so he was able to use that equipment to help further company ideas before they were ready to spawn off. And they had a tremendous impact in the recent pandemic as well. If we look at the liquid nanoparticle work of Dr. Cullis, which is simply stupendous and is the reason in large part that we were able to deliver those mRNA vaccines into people, hundreds of millions of people worldwide as a society. One of the interesting aspects of his work is how long it took to get to a place where it could be commercialized. So he recently cited at our launch of our BioHub that it was a 25-year journey funded by the federal government that allowed the technology to develop to the point where it was ready in this instance to really accelerate the therapeutics that could be delivered out to not only Canadians, but to the world. So I think you see that need for incubation within the university, both for research and for innovation, and also the need to really fund fundamental research because we never know where the next discovery that's going to significantly impact the world is going to come from.
Well, thank you. And you also mentioned in your opening remarks about a need for more funding for, I think it was just for patent production, how that aspect needed more funding. And I just wondered if you could expand on that, where that money is needed, what it would produce.
Absolutely. So at UBC, inventions are provided to the university because we are institution-owned institution policy that we take towards IP. When they're when they are disclosed, there is an analysis that is taken to determine what should be patented. Our patent budget is very small, and we stretch it in multiple ways to be able to file those over 300 patents that we filed last year. If we don't protect that intellectual property at its inception, then over time, we lose the ability as a country to even think about commercializing that technology. So the more that we can file provisional patents to work on patent families, to get those fundamental patents in place, the more that our researchers and Canadians have an ability to think about how we can commercialize that further.
And just to expound on that further, I assume there's a time constraint too in that patent filing, because you have, these researchers will want to publish their results, and once those results are published, I assume patenting becomes more difficult.
Yes, it does, and indeed we take care in making sure that all of the research that's done at UBC is publishable, can be publishable. So that is a goal that every researcher has, every graduate student needs to be able to strive for. So we need to be able to act quickly, and it is not something where you can take years and years to think about filing the patent.
Okay, and just one more follow-up on that, and that is the role that governments could play in government procurement. We were talking about vaccines. Where do we need more government activity in, say, producing vaccines compared with the UK example, when Canada literally failed in that regard to produce things at a real commercial level? Where do we need that government procurement?
So what I know from the health system, and I'm sure Dr. Galley can speak more to this, is Canada is one of the hardest places to have your invention taken up into the healthcare system. So we need to not only be able to produce, which the biomanufacturing and life sciences strategy is taking a step towards, not only the vaccines, but also producing the ingredients that go, the supply chain that goes into the vaccine production. And then we need an ability to actually procure at some scale to be able to move that into use. Before that step, we have to also be able to do early stage human trials, which is not the easiest thing to do in every part of this country. So those are where I know our researchers are working with Health Canada to be able to keep some of the regulatory changes that happened during the pandemic, to be able to regularize those and be able to then move some of the therapeutics more quickly into Canadian use.
Merci, député Cannings. Le temps est écoulé.
Thank you, Mr. Cannings. Your time is up. We'll now go to the second round. We have 5-minute rounds. We'll go to MP Mazur.
Thank you, Chair. Thank you for the witnesses for coming here today. Dr. Murphy and Dr. Galley, can you please table with this committee how much money your university has received from the federal government for research and how much your university has made from licensing of intellectual property over the last 5 years? Can you table that report, please?
We could certainly get that information to you.
Dr. Galley as well?
Yes.
And also, can you table with this committee what percentage of your IP has been transferred to Canadian companies and non-Canadian companies over the last 5 years?
We can certainly also do so. I can say with respect to licensing out to companies, we have 2 forms, sponsored research, as I mentioned, the vast majority of which is going to Canadian companies. The second spinoff companies, 92% of that went into Canadian companies, 8% went to US and UK companies, where there was not as much of an ability to find the market and accelerate it in Canada.
Okay, if you could table those 2 reports, that'd be great. And Dr. Galley, I have a patent application with me here. The international publication date is June 11th, 2020. The publication number is WO 2020/113310A1. The application's names are Huawei Technologies and the University of Calgary. How many patents has your university applied for with or transferred to Huawei?
That's also a question that can be answered in terms of the quantitative details after the fact. I don't have those numbers at my fingertips as I'm here. I think your question is, of course, a very pertinent one, particularly in the current time where There is a heightened attention to matters of research security. We are working under some new federal guidelines for safeguarding our research. And those guidelines are accompanied by new bodies that have been created within CSIS and Public Safety Canada to support post-secondary institutions in the consideration of research security and
That's
management
good, Doctor.
of risk.
Thank you. I have some more questions here. Do you continue to work with Huawei in any form?
Not at this time because of guidance that has come to us through the bodies I just mentioned.
Okay. Dr. Murphy, I have a patent assignment agreement here with me. And the conveying party is your university, the University of British Columbia. The receiving party is Huawei Technologies. And I'm quoting from the assignment agreement. We, the University of British Columbia, do hereby sell, transfer, and assign to Huawei Technologies Canada all our interest in inventions and developments relating to photonic elements driven by common electrical driver, including the inventions and developments disclosed in the United States Utility Patent Application, serial number 15/080065. And we grant to the assignee all right, title, and interest in any and all intellectual property therein. The patent assignment agreement was dated July 2021. How many patents has the University of British Columbia filed with or transferred to Huawei?
Again, I would be happy to table that information, the quantitative information later. I can say as the research security guidelines have evolved with the federal government, we have been changing our agreements in that respect and have moved to new standards.
Do you continue to work with Huawei in any form?
Yes, we do.
Thank you. No further questions, Chair.
Merci, député Messier. La parole est maintenant.
Thank you, Mr. Mazer. We'll now go to MP Collins for 5 minutes.
Thanks, Mr. Chairman, and welcome to the witnesses this morning. I'll start with and this question is for both witnesses. A previous 2017 study here in Ottawa focused on IP, and it highlighted that private firms do not know what research is being performed at post-secondary institutions and what IP they hold and how to leverage it. One of the recommendations was to create a mapping program that would enable the private sector to better forge partnerships and links with post-secondary institutions. And so can I ask, and I'll start with you, Dr. Galley, your thoughts on that in terms of ensuring that local partners, prospective investments that could be made by the private sector, how does the university deal with that issue? And what are your thoughts in terms of the federal government playing a role in sort of being a matchmaker to ensure that those private investments continue to flow to post-secondary institutions?
Thank you very much for that question, and I think it's really a pertinent one. As I said earlier, the partnership programs of the Tri-Council agencies are a valuable catalyst because they explicitly connect universities with companies, and they incentivize those connections and they subsidize those connections by bringing some public sector funding to the table that both the universities and private sector partner can benefit from. That said, there needs to be more direct university private sector engagement, and I think that some universities are stronger than others. At the University of Calgary, we have ramped up our industry partnerships function. We don't want emails sitting in the inbox of an executive vice president who's drowning in email. We need to have an office that can answer same day, do some matchmaking of researchers with companies, have dialogue of shared interests, shared challenges. We talk a lot about push and pull in science, and actually, paradoxically, often it's the pull science where there's an external partner engaging with universities saying, can you help with this? That can be most impactful, because the valley of death is already partially bridged when that's happening. So really trying to ramp that up. Can governments, plural, support that kind of industry industry university bridging, I think they can through potential creative programs. I'll turn it over to Dr. Murphy if she has anything to add.
Thank you.
Yes, just building on that, we also have extensive partnership work that goes on. I think there's two opportunities to further this. There was in the Liberal platform a University Knowledge Mobilization and Commercialization Fund. I think if we were able to mobilize that, we would be able to have more universities engaging in partnerships. And the second is the new Canada Innovation Corporation, where there is an intent to help businesses grow. They can help grow with the help of universities, and making sure that we're actually able to broker relationships between university researchers and those companies could help us take things out of the lab and increase that pool.
Thanks. By extension, I've had the opportunity to visit McMaster's Innovation Park, where they are leveraging private investment, but they're also leveraging municipal and provincial investments as well. What role can the federal government play in terms of incentivizing municipalities and/or the provinces to make the same kind of investments that we're making here in Ottawa? Can I start with Professor Murphy?
I think trying to get all levels of government working together is definitely a laudable goal and one we should continue to work towards, and would love to learn more from the McMaster model. I think the more that we can ensure that companies can grow in terms of planning of space of municipalities, and then have provincial and federal governments in particular help co-fund the early stages of companies, make sure that they have a place to start out, be able to maximize the investment that went into the federal research dollars.
Dr. Galley, I got about 30 seconds left on that issue.
Yeah. Just very quickly, we're beneficiary at this university of municipal funding through something called the Opportunity Calgary Investment Fund that is for innovation programs. We have a provincial Alberta Innovates agency and a Ministry of Innovation and Technology that provides us with support in many areas, and of course, the substantial federal government programs. I like leveraging programs. I know that intergovernmental relations sometimes are stressed by those matching programs, but the notion of matching is a good one. We have provincially funded post-secondaries that rely heavily on federal government funding.
Merci, député Collins. Le temps est écoulé.
Thank you, Mr. Collins. Your time is up. We'll now go on to the 2.5-minute round. We'll start with Mr. Cannings.
Merci.
Thank you.
Coincidentally, just before this meeting, I met with U15, the organization that supports and promotes research in Canada's largest research universities. And it was mentioned that the advisory panel report on the research support system just came out. And of course, U15 has also been asking for increased support from the government for the whole research ecosystem in Canada. I've been advocating for better scholarship funding for graduate students, but also, this report asks that more money be put into the tri-councils to both hire more researchers and give them more funding so that they can support grad students as well. And I'm just wondering if both Dr. Galley and Dr. Murphy could comment on that. We'll start with Dr. Galley so that he can have first dibs this time.
It's still easier going after Dr. Murphy, but no, I'll just say the report's very interesting, and I think it's it has balanced consideration of funding, but also how the governance of the funding agencies is structured. It addresses major science infrastructure, which is an important challenge for all countries, and not the least of which Canada. And it also considers the connection between research and innovation, which I know, and the pathways to commercialization, which I know is the focus of this committee. Many, many interesting elements here. And I find myself endorsing this largely. I think this is, want to have a conversation at the U15 table in early April on what each of these elements mean. But I think it's a very compelling document. I'll turn it over to Dr. Murphy.
Yes, I agree. It's a very compelling document, and I'll pick up on one piece that you already mentioned, Mr. Cannings, and that is people. What we haven't focused on perhaps enough in this discussion is that innovation starts with people and it continues with people until it is out there and being used often by people as well. So funding our graduate students that are such an incredibly important conduit of the talent that we put out into the world, that are often the genesis of amazing ideas that become companies that help people like Professor Cullis develop liquid nanoparticles. We need to invest in people in Canada. And our current investment levels are substandard internationally. We're seeing drop-offs in our application rates. We will start seeing drop-offs in acceptance rates of bringing people into Canada and of our own Canadians and staying here to do graduate studies and then continue on into our economy. So I think it's fundamentally important that we consider the levels and the numbers of people that we're supporting through any policies and programs we put into place.
Merci, député Cannings.
Thank you, Mr. Cannings. Your time is up. We're going to 5-minute rounds, and we've got MP Soroka up.
Thank you, Mr. Chair, and welcome to the role. I'll start off, and welcome to our Dr. Murphy and Dr. Galley as well for coming today. I'll start off with Dr. Galley. Canada colleges have proven that applied research works on partnering with private business and allowing them to own their IP. Does that ever happen with universities?
Yes, absolutely. I think that there are all kinds of industry partnerships. There are some where an industry partner wants very early stage concept discussion, and there might even be a co-creation of IP pathway. There are other situations where the partnership is centered around an industry-owned technology where there's a desire to validate, refine, demonstrate impact in an applied sector, and our partnership agreements that I think would be true for our whole sector usually lay out the nature of the agreement. We're trying to be sophisticated and fast and customer friendly as a university when we engage with industry, so that the experience for the industry partner is a positive one. And I think we have some work to do in the sector probably to be very focused on customer experience and the customer being industry partners.
Okay, thank you for that. Also, Dr. Galley, who are the members of Autumn, and how does this help commercialization of IP in Canada?
You catch me a little bit off guard, just to because I would
that information if you'd like.
Yes, I will. Yeah,
I'd appreciate that if it in a written form. Dr. Murphy, you stated in the opening that your company exited to Planview, which is based in Texas. What do you think we need to see in Canada to see more exits to Canadian companies?
Thank you for that question. And yes, that was an exit after 15 years of growing the company in Canada, and it's retained significant offices within Canada and development within Canada. One of the challenges is just being in economic sectors that have the growth to be able to continue growing within Canada and to have the market capital available and the customers available to continue to grow within Canada. So as we grow the sectors, as we grow companies larger and larger, start creating that ecosystem. Within BC, I think we're creating that ecosystem in biotech, and we're seeing that the companies are choosing to stay, and people are able to move between those companies, providing some cross-fertilization.
Oh, well, that's good to hear, to be honest with you. Also, Dr. Murphy, what is the single largest roadblock to inventors trying to commercialize their IP, and how do we fix it?
If there was only one roadblock, I think it would be a lot easier of a problem to fix. I think there are different roadblocks for every sector, and that's some of the work that is going on in post-secondary institutions like my own, like Dr. Galley's, to try to understand where those roadblocks are and to try to start understanding how we can address them. Some of them we've talked about a lot today. How do we get patents into place? How do we get pilots built to a size where it's interesting for investors in taking out into a company? How do we be able to get procurement so those companies can grow here in Canada and not face the challenges that I faced in my own company of international sales from day one?
Okay.
And I just wanted to add that one of the biggest roadblocks is failure. And failure is a predictable outcome in these pathways, and that's where the mentorship programs are so key to support a resiliency, a step back, try again, modify approach, etc.
Okay, thank you, Dr. Galley, for that as well. I guess my concern was more, do you think the roadblocks are either through legislation that the government has handled, or is it lack of funding? Are those the primary ones, or would you say there's other factors as well?
I can go first if you would like, Dr. Galley. I think that funding is a huge one that I'm hearing about often. The inability to have Canadian lead investors invest in companies at a risky stage and keep the company firmly anchored in Canada. A second one is simply ensuring that we have the sales and marketing people still to be able to have the expertise to grow the companies in Canada. So those are definitely two that I hear our companies facing.
Galley?
You know, the second part of your question you said, or is it a combination of factors? I think it's a combination of factors. That it's not an easy space, and we know that the pathways to commercialization have successes, but also many ventures that fall off and don't make it, and that's part of innovation ecosystems. Nevertheless, I do endorse Dr. Murphy's comment that, of course, funding pathways are a big part of it. We have the programs that I mentioned, the USEED program, and I didn't mention CDL, Creative Destruction Labs. We have a CDL Rockies franchise, and that exposes many of our university ventures to angel investing, and those funding pathways are helpful, as are government programs.
Merci, député Soroka. Nous poursuivons maintenant.
Thank you, Mr. Soroka. We're still on the 5-minute round, and we'll go to Mr. Longfield.
Thank you again, and you're doing a great job. I'm going to start my questions off with Dr. Murphy. I was co-founder of Innovation Guelph. It was an innovation ecosystem, or it is an innovation ecosystem in Guelph. On the governance model, we have the University of Guelph sitting on the board of directors of Innovation Guelph, and the businesses in Guelph are also quite tied in with Created in Guelph, an innovation center out of the University of Guelph. I've been to Innovation UBC, and tremendous work, as you said, is going on particularly on the liquid nanoparticles, but other health innovation. The University of Guelph is doing innovation around corn-based nanoparticles that cancer drugs are attached to and then put into the body. The corn is absorbed by the body, and the drugs do their work on specific cancers. But the UBC didn't know what Guelph was doing, and Guelph didn't know what UBC was doing. I'm wondering, how do we develop an ecosystem in Canada where universities are aware of the research that's being commercialized that they could take benefits from each other on?
Yes, thank you for the question. And sorry, the lights turned off. We're very into sustainability here at UBC. One of the challenges is, as you say, connecting the ecosystem across the country. We should also mention that the U15 has created a database for people to be able to search across the federal agency databases, through patent databases, to be able, for both researchers and companies, to understand who's doing what within the country. I think we need to train up our partnership people, the people that are supporting our innovation, to look for those connections. And then once we make those connections, one of the places where we need to do better in this country is funding collaborations across the country. We have various programs that come and go, but we need to be able to connect, as you said, to be able to really understand where we can take those next steps together. And so collaboration funding would also be extremely welcome.
Great. And as you mentioned earlier in your testimony, the provincial funding and the provincial, there's a whole provincial piece, and then there's the federal piece, and quite often there isn't a connection. But we do have programs like the Engage grants with IRAP as well, and IRAP now with regional agencies that we're looking at developing better communications. We have the MyTax system. So we do have federal programs that are common across university innovation ecosystems. Could you comment on the benefit of those in the way they bring industry into the university innovation ecosystem?
So many of those programs help facilitate those initial introductions between companies and researchers, and start off the ability to connect. I do think that for companies, sometimes it's a lot of people coming at them that say they have somebody who can help them in a university. And so the more that we can coalesce some of those relationships, I think the better off that we'll be. We do have a great network across the country of both My Tax Business Development and NRC IRAP individuals. We know that IRAP will be folded into the new Canada Innovation Corporation. So I think we need, as we do that, to make sure we also have the connections into the universities. It's very difficult from someone outside to know the complexity of the university landscape. And so we have had success in having people that are dedicated to partnerships internally and that can help bridge that gap to then get to the researchers who are often extremely busy with both their research, but also the teaching commitments they have to make sure we have educated Canadians.
Great, thank you. And Dr. Galley, I also was fortunate to visit Innovate Calgary to see what was going on there, and incredible work in the different pillars that you're working on. Of course, the energy transition being one of the key areas of development that industry is looking for support. But sometimes the funding models of universities in Canada, I'm not saying University of Calgary in particular, but the royalty streams that come from innovations or IP that's owned by the university, or the funding that comes to a university from industry to finance innovation, is in competition with industry getting funding from, let's say, government sources. Could you comment on following the dollar trail on innovation funding and how the government can help to encourage investment from industry into the university network?
Yeah, no, thank you. I'll just make one quick comment about our IP policy. We have a creator-owned IP policy at the University of Calgary, and have received some strategic input from an investor community here in Alberta that suggested that historical levels of IP claimed by the university were too high and indeed a barrier to company creation. So one of the interventions that occurred a number of years ago was a change to the creator-owned IP and a rather small university claim in ventures. To your other piece, this is I know you are a parliamentary committee where science policy is in play, as I said in my comments, and I think that the business private sector expenditures in R&D being so modest in Canada, I do wonder about tax incentives for increased private sector spending on R&D and as a potential lever.
Thank you.
Merci, député Longfield. C'est ce qui met.
Thank you, Mr. Longfield. This is the end of our first hour. I'd like to thank Dr. Murphy and Galley. We're going to suspend the meeting for a few moments and get ready for our next group of witnesses.
J'aimerais faire quelques observations.
I'd like to make some remarks for our witnesses. Thank you for joining us. Now, before you speak, please wait for me to name you. If you're participating by video conference, click on the microphone icon to activate your microphone, and please mute yourself when you're not speaking. Regarding interpretation, for those of you on Zoom, you have a choice at the bottom of your screen between floor, English, or French. For those of you in the room, you can use your earpiece and choose the channel you want. I would like to remind you that all comments from members and witnesses should be directed through the chair. I'd like to now welcome our witnesses. From the University of Saskatchewan, Bajit Singh, Vice President Research, and from Triumph Innovations, Catherine Hayashi, Executive Director. We'll now move on to the opening remarks. You'll have 5 minutes each. Please start, Professor Singh. You have the floor.
Thank you very much, Mr. Chair, for this opportunity to be in front of this committee. It's quite a privilege. I hope someday I will get a chance to visit with the committee in person as well. I am speaking from Treaty 6 territories and the homeland of the Métis, and where we continue to advance our Indigenous engagement with the communities in this province. I also thank the committee for taking this very important question for discussion. And at the University of Saskatchewan, we have been engaged in moving intellectual property or the knowledge for the benefit of the end users and in the service of prosperity of our province and the country. Recently, there was also an advisory panel which was struck by the Honourable Minister of ISED and Health Canada, Minister Champagne and Minister Duclos, respectively. I had the privilege and honour of being a member of that 7-member panel. So we were deeply engaged in the discussion on moving intellectual property to commercialization, and the report was released yesterday, which the committee already has seen. I'm going to speak in 2 parts. The first, I want to share some examples as to where we have been very successful in moving intellectual property to commercialization, and a couple of points that come to my mind as to how we can strengthen the system further. When the province of Saskatchewan was created in 1905, the university was established within 2 years of that to really strengthen and grow the agri-food production system in the province of Saskatchewan. The university's College of Agriculture created a system called Farm Train, where the researchers from the university will go to the farmers directly where they were tilling their land to provide the latest knowledge in agronomy and watering, in crop science, in harvesting technologies. And that has led to what we today have, a multi-billion-dollar agri-food enterprise in our province. Within that period, the university created a crop development center, which from 1971 till today has released more than 500 varieties of crops. Now, if you figure it out in a timeline, that is 1 new variety every month or month and a half. And no wonder that in Western Canada, we are a powerhouse when it comes to food production system. So this was a collaboration between the university, the producers, and the federal and the provincial government's investment in the agri-food discovery knowledge system. The second example to really flesh out the point is the collaboration that happened between multiple universities and led to the creation of a vaccine against a virus that affects the pigs. But before that, there was a step where the discovery science comes into play, which is so well funded by our tri-councils in our country. The researchers at University of Saskatchewan discovered a virus which led to the development of a vaccine in collaboration with the Queen's University, Belfast, Ireland, and the Ohio State University in the US. That vaccine technology was purchased by a company in France. Although we got more than $100 million in royalties to the university and the inventors, but the job creation took place in France. And we need to think about an ecosystem in this country that goes from end to end, and we can take our intellectual property and develop the job jobs in Canada. Now, there are 3 points which I want to make to really advance our discussion. Number one, we need to keep on making investment in our federal research support system that we have in this country. I believe, based on the discussions that we have taken over the last year, that countries like US, Germany, Norway, France, India, Brazil are really moving ahead at a very fast pace when it comes to making investments. Number two, the ecosystem that we need to create, in which the university's creation of intellectual property can be strengthened in two ways. Number one, that middle tier where we go from technology readiness level 3 to 7 needs to be somehow created, where small and medium economic enterprises can work with the university through a support system from the federal and the provincial government. The another investment is in the training of the researchers, graduate students, and the young researchers, so that they can keep an eye on their inventions and how they can connect it to the private sector through commercialization pipelines that we can establish and support within our country. So training of the young minds, retention, training, then also strengthening support for that TRL 3 to 7, how we can connect that piece. So, Mr. Chair, I will stop here and look forward to the discussion with the committee for the remainder of the time. Thank you.
Merci, Professeur Singh. La parole est...
Thank you, Professor Singh. We'll now go to you, Ms. Hayashi. You have 5 minutes.
Hello, Vice Chair and committee members. Thank you so much for inviting Triumph Innovations to appear before you on this important study. My name is Catherine Hayashi. I'm President and CEO of Triumph Innovations, the business interface and commercialization arm of Triumph, Canada's Particle Accelerator Centre. Before I begin, I'd like to acknowledge that Triumph is located on the traditional, ancestral, and unceded territory of the Musqueam people, who for millennia have passed on their culture, history, and traditions from one generation to the next on this site. Triumph's home has always been a seat of learning. Located on the campus of the University of British Columbia, Triumph is a world-class subatomic physics and accelerator facility that, using world-unique infrastructure, carries out fundamental science and applied research that is changing the world. Triumph's network of innovators, which includes 21 Canadian universities, is constantly developing new tools and techniques that push the frontiers of knowledge. These scientific innovations hold immense promise for the world beyond the lab, including the marketplace. Our dedicated team of business and technology transfer professionals at Triumph Innovations connects scientific inventions and ideas from particle detectors to isotope manufacturing systems, and the innovators behind them to opportunities in the private sector. Triumph Innovations acts as a connector to the business world by providing market opportunities for applied technologies that emerge from the Triumph network, by streamlining access to our world-class expertise and infrastructure, and by connecting our researchers and technologies to the world via industry partnerships, company creation, and licensing. The work of Triumph is sometimes seen as merely theoretical with little practical impact. The truth is that our work is often applied in ways we cannot foresee at the outset, with often surprising commercial and societal benefits. During the COVID pandemic, Triumph used learnings from research looking for dark matter, which included experience with gas handling and control systems, to help engineer and produce low-cost COVID ventilators through partnerships with other Canadian institutions, Italy, and the United States. Another real-world application is seen in our spin-off company, Ideon Technologies, which uses muon detectors originally developed to study fundamental subatomic particles as part of a new technology that provides X-ray-like visibility up to 1 kilometer beneath the Earth's surface. By detecting muons and using proprietary algorithms to produce 3D maps, Ideon helps exploration geologists more accurately identify new mineral and metal deposits, allowing companies to mine in a greener, more cost-effective way. Ideon is the lead for a unique digital supercluster project with a world-leading consortium, which includes Diaz Geophysical, Fireweed Metals, Simon Fraser University, Mitax, and Microsoft. None of these advancements would be possible without first providing the necessary funding and resources to the fundamental research being done at Triumph, as well as funding to enable our researchers to devote more focus and more applied activities to successfully develop and commercialize intellectual property. Future success will require even broader collaborative research and funding approaches across disciplinary boundaries. As part of our recently released 20-year vision, we are continuing to focus on what we do best, translating fundamental science to real-world applications. We are excited about the opportunities for Triumph to drive further scientific breakthroughs and solutions to complex challenges facing Canada and the world, ranging from climate change to health to quantum and green technologies. Triumph's newest capital investment, the Institute for Advanced Medical Isotopes, will provide academic and industry partners with world-leading capacity for new isotope research and clinical applications, and forms an important building block in our growing national medical isotope ecosystem. In summary, our team at Triumph and Triumph Innovations continues to work tirelessly to translate Canadian scientific IP to real-world applications. Through our partnerships, we are bridging the gap between applied and theoretical research and tangible innovations. As you continue to study the commercialization of IP, as well as your study into big science in Canada, we look forward to hosting you at our facility in Vancouver and showcasing the amazing work we are doing to drive innovation. Thank you, and I look forward to the committee's questions.
Merci, Madame Hayashi. Donc, nous débutons.
Thank you very much. We'll now start with the 6-minute round, and we'll go to Mr. Williams. Thank you very much, Mr. Chair.
So, Ms. Husky, thank you for being here today. This is fascinating information. I want to start with how does Canada, first of all, become number one in medical isotope IP creation?
We have an incredible base to build on. So, Canada has been a leader in this space for decades, and I say that quite seriously because I think that Canada is a small country in the stage, but we punch above our weight in the medical isotope space. We have decades of investment in cyclotrons and reactors across the country that give us an edge that we can leverage in a booming sector. So we're seeing advances in radiopharmaceutical development that are really changing the way that we treat cancer. Medical isotopes used to be used for imaging, which is also an extremely important part of healthcare. But when you have isotopes that are playing a role in treating cancer that is otherwise untreatable, those are exciting developments. And Canada is poised with the components of an ecosystem all the way from research through to commercial supply and radiopharmaceutical development to really take our place on the global stage.
So a lot of witnesses in the past have talked about how the Americans have a robust VC system. They have more of the ability, it seems, to take risk when it comes to investing. So when we have IP developed and we see the medical isotope ISP ready in Canada and we have companies that have started up and are growing, are you seeing from your industry that we have enough risk takers, investors, VCs in Canada, or are a lot of these coming from overseas or from the U.S.?
I think it's a common feeling that we do have a shortage of risk capital in Canada. It is a key component, and I think as some of the other witnesses talked about, it's not the only component, but it is a key component in that valley of death that early stage technologies face. Many Canadian companies do have to build consortiums of investors that include investors from outside of Canada. And that's the current reality of risk capital in Canada. But I think anything that we could do to strengthen that base in Canada will help the whole ecosystem.
So do you have any specific recommendations that you've heard from your industry or that you'd have personally on how do we increase risk capital in Canada?
I think that it's been studied for a long time. I think that having government matching or tax incentives to attract more of those capital pools to be built in Canada and to continue to grow. A lot of firms have trouble continuing to kind of re-up on their investments. They may come in early, but then not have the capital to continue investing in, particularly in the radiopharmaceutical space, where it takes many hundreds of millions of dollars to develop a successful product. You need to be able to continue to reinvest along the way.
Okay, thank you very much. Mr. Singh, you talked about a 7-member panel that you've been involved with on IP commercialization. you said it was released yesterday. Is that correct? I haven't seen the study. I don't know if many of the members of the committee could you submit that report to the committee? And maybe I'm asking you right now, sir, maybe just give us a quick summarization of that report and what were the biggest findings of that?
Thank you very much. The report was actually focused on federal research support system, and within that, there's a component of study and recommendation focused on how to connect our innovations, inventions to commercialization. Because when we took consultation across our country, people from private sector also came to speak to the panel. The report was released by ISED yesterday. It's on their website. I will be very happy to submit the report to the committee. So, for example, as other panelists previous to me this morning have spoken, that we have basic elements of the system in place. One of the challenges in Canada, which is a large, diverse country, is the connectivity of the system, various elements to each other. How does universities create business-facing entities within their environment so that the private sector investors can come looking for a technology to the university and the universities can talk to the private sector? Simply creating a database where people can search for the patents, connect with each other, and go from there. The lack of the risk capital investment in our country, I believe, considering the size of the country, we may have some appropriate amount of investments available, but I think the role of the federal and the provincial governments to tie it together into a package by creating incentives, blended funding, and the speed with which we can create the blended funding to invest in a technology is something which we need to tighten up. And that's one of the recommendations in the report which we have made. And the second part within that is the training program. I think in our universities, we need to create an investment where graduate students, postdoctoral fellows, and newly recruited professors are much better savvy, flexible, and keep an eye on commercialization and creating an economic advantage for our country when they create a technology. So I think that ecosystem connect is something that we were focused on, and we would really like to see the next steps on the report which we have submitted to the federal government to see some action on that. So these are the 2 points based on the recommendations I submit to you and the committee.
Thank you. Mr. Chair, do I have time left? We're done.
C'est terminé, député Williams. Merci.
No, Mr. Williams, your time is up. We'll now go to Ms. Diab. You have 6 minutes.
Merci beaucoup.
Thank you very much, Mr. Chair.
Bienvenue à notre thème.
And welcome to our witnesses this morning, or this afternoon, rather.
Today. Let me just first ask you, Mr. Singh, you spoke about, and you were asked by Mr. Williams about the report that was just released yesterday. And you talked about your university in Saskatchewan being a powerhouse for food production system and the collaboration that you have seen in order to get the university to that stage. Can you just elaborate a little bit more and tell us if there's other places in Canada that are sort of doing similar things like that, or what collaborations do you have outside of Saskatchewan within Canada?
Respectfully, are you asking about the agri-food system or the broader question, please?
The agri-food.
Agri-food. So I think in Canada, we can be so proud of our agri-food production system, plant and animals both, from Prince Edward Island to University of British Columbia. Whether we look at the veterinary medical faculty at University of Montreal or the agriculture college at Laval or at Guelph or Manitoba, you just name it. If you look at the growth of our country, which grew out of the land production system-based economy, and where we are today, I think the role of the veterinary and agriculture colleges is very preeminent. When we look at Ontario Veterinary College or the Ontario Agriculture College, their contribution to turning Ontario into a production house when it comes to pork, to poultry, to the plant system is there. Taking home the example from Saskatchewan over the last 115 years, through creation of the knowledge, which is in response to the challenges that our farmers face, has really galvanized our food production system, not only on the sustainability front, that we sustain our land, we steward our water resources, and we steward our environmental care, but actually about $18 billion in food production export from the province of Saskatchewan. Now, again, if I may say, it is about connectedness. Once we have connected the end users to the people who are discovering new knowledge, then the cycle keeps on amplifying itself over and over again. Now, within that space, there are developments. For example, the creation of the superclusters or the global cluster. Within the ecosystem of Saskatchewan, now we have a Protein Industries of Canada, a global cluster. Now that's where we are trying to convert our agri-food product into a protein product at the end of the day that the world needs in greater and greater amounts from India to Africa to Bangladesh and anywhere else. So the evolution of the system over the 115 years in sophistication, in investment, I think has been shown by our agri-food production system as to how we can do better from discovery to an economic product at the end of the day.
So in Nova Scotia, we have we have the Agricultural College, for example, that's been doing really good things. I guess how can we better collaborate and cooperate and sort of work together across the country so that we learn best practices? And that's one question. And the second question is, in terms of research processes for academics, when do you believe researchers and academics should start engaging with commercialization and intellectual property, if at all?
Thank you. The first part of the question is, I'm a veterinarian by training. I have taught in Prince Edward Island. I have visited that beautiful college in Truro, Nova Scotia. Like specifically, that college has made contribution to agri-food policy in our country in a significant way. And I'm very proud of the work that happened at Nova Scotia Agriculture College, which is now part of the Dalhousie University. And it's a truly a jewel in our country. And the colleges across the country are connected already through a Dean's Council, which meets every third to fourth month. I used to be a member of that council. We will exchange ideas, programmatic information, and how to work together and working with the federal and the provincial jurisdictions. The second part of your question is, at what stage? Never too early, because sometimes it is the eye on the discovery of a new knowledge that makes a difference. How do we protect that intellectual property? How do we put a patent on it? And before it disappears anywhere else, how do we work with the private sector to mobilize it? And that's where, respectfully, I was making the case on really speeding up our education system for graduate students, new professors, to sensitize them to the idea of intellectual property, because that could be a multi-billion-dollar enterprise coming out of that piece.
So
Radioisotopes.
So thank you very much for that. Just very quickly to Triumph, I just want to congratulate you and for all the work that you folks are doing to really bring everything to light. And of course, maybe I'll just give you a few seconds, and I'm sure my colleagues will ask on that, maybe just a bit on the Snow Lab facility.
Snow Lab is one of our kind of sister labs in Canada. They do remarkable work. If you ever get a chance to visit, you should. It is a lab that is deep underground. It shares a mining space with an actual mining company, and the kind of experiments they do there are remarkable. I mean, they have detectors that they've built, giant detectors that they've built underground that they're trying to detect rare particles with. And, that's kind of the magic of science. I do think that this idea of, providing those brilliant researchers with bandwidth, time and funding to take those brilliant minds and turn them to real world problems is something that we're very interested in. We have had experience with the old NCE CSER program, the Centers of Excellence for Commercialization and Research, which provided funding to Triumph Innovations to focus on developing technologies with real world applications. That's where IDEON was born. We also had the good fortune of being part of an NRCan ITAP project which brought together Triumph
Madame
as
Hayashi,
well.
pardonnez-moi de vous interrompre.
I'm sorry I have to interrupt you, but the time is up. We're now going to move on to Mr. Cannings for 6 minutes.
Well, thank you, and thanks to both the witnesses for being here today. I'd like to start with Dr. Singh. You mentioned, I think, 500 varieties that your group have patents on or some IP protection on over the last years. I come from the Okanagan Valley, where we have the Agriculture and Agri-Food Canada research station, which I'm very familiar with its development of tree fruit varieties. For instance, whenever I go traveling in the world and I see cherries for sale, I always ask what kind of cherries they are, and they're almost always cherries developed not only in Canada but in that research station in Summerland. And I guess I want to get a sense of the history of protecting IP for these varieties. You know, one of the commonest cherries varieties is Lapins. It has no patent protection. It's used freely around the world. I know for the last 20 years or so, I think the Canadian government has been patenting those varieties. But perhaps you can talk about, you know, the history of protecting IP on production of new varieties of plants and anything for our agriculture sector.
Thank you very much. As is the case with the intellectual property protection, it has evolved over the last many decades to a point where the germplasm of the plants and animals is considered as a national treasure and a resource. Countries are becoming quite protective of the germplasm. In Saskatchewan, at the University of Saskatchewan, most of the varieties early on were released directly in partnership with the producer groups for them to cultivate it across the country, and there was not any rigorous intellectual property protection on them. Over the years, the Crop Development Center, in partnership with the producer groups, for example, whether they're canola, whether they're lentils, whether it's wheat, now we work in partnership with them to protect the seed lines, the variety lines, which are housed at the Crop Development Center. They are in partnership still with the producers, and we release to them directly. And the control of the release of those varieties is still in partnership with the CDC and the producer groups. The intellectual property piece still is done because producer groups are the ones that are taking the varieties from us, particular producer groups, and they are releasing it to them. The exact number of the varieties that we might put an intellectual property or patent on is something I can't recall right now, but I will be happy to submit a one-page brief to this committee in a matter of days within this week. I will be happy to do that.
Right, and do you know if there's any differences perhaps between putting IP protection on or patenting varieties of living things versus the other inventions and innovations we've been talking about here over the last few weeks? Is there certain things that we should be aware of on, you know, the timing of this, how it's done, who does it, just so that we can get a sense of how we can best protect these Canadian innovations?
Right, and I think the one difference that I can speak to is the way we produce our crops compared to creating a product in a factory. And the seed lines, the varieties, the cultivars that we have, they are eventually turned into a seed. And the seed is released through a regulatory mechanism after it has been approved by the Canadian Food Inspection Agency, for example, or Agriculture, Agri-Food Canada, then it's released into the market. The sale of the seed that we might produce in overseas and other countries, again, it possibly is transferred over to the seed production companies that sell it globally under licensing from the inventors. But again, I don't have the full details on it, but I will be again very happy to submit a brief to the committee.
Well, thank you. And I'll turn now to Dr. Hayashi, and I'm really looking forward to a visit to Triumph. Hopefully we'll be allowed to travel and see your facility again. It's been many years since I've been there. We just heard from Dr. Murphy of the UBC, Vice President for Research and innovation. How closely do you work with UBC as a whole in your work, especially with regards to IP development?
Of course, we do work very closely with our member universities, and as we're on the UBC campus, we interact with UBC significantly. One of the great resources that we have been interacting with is their Creative Destruction Lab program, which I think was mentioned in the earlier session, which brings together a remarkable community of innovators, investors, researchers, trainees, all trying to find commercialization paths for innovative new technologies. So we found some excellent connections and investors for our spin-off companies through the Creative Destruction Lab program at UBC. And then, of course, whenever we have a project that has IP potential, one of the things that we always do is create a project agreement where it's very clear how the IP is handled, who will be taking the lead on commercialization of that IP, how the funding will work, whether there are project milestones, clearly laying out project budgets, funding sources, et cetera. So I think that we really developed a good working relationship with UBC and our other partner universities in technology innovation.
10 secondes, député Cannings.
10 seconds.
Thank you. Merci à vous.
We'll now move on to the second round, 5-minute round, and we'll go to Mr. Lobb.
Thank you very much, Mr. Chair. My first question is for Ms. Hayashi, and it's in regards to the isotopes. And I'm pretty sure I saw a video of you one time. No, I mean a video at a dinner, and it was in regards to your work with Bruce Power. And I was just wondering, is that correct, that Triumph has a working relationship with Bruce Power and the medical isotopes they produce in their reactors?
In a way, so we are all part of the group that is working on the Canadian Medical Isotope Ecosystem proposal that is part of the Strategic Innovation Fund Stream 5, building new national ecosystems. So that is what we have been hard at work doing for the past few years. Bruce Power is one of the main partners in that effort. They have a project that's really unique, that is taking the reactors that they use to generate power and using them to co-produce medical isotopes. Their part of the project is really innovative, and they also have a really important economic reconciliation component that involves the Saugeen Ojibwe Nation that we're very excited about, medical isotopes playing a role in that relationship. So yes, we did do, and actually it wasn't us, and a group of independent filmmakers made a 10-minute film talking about actinium-225, which they called the rarest drug in the world, and that has gone viral a little bit. And so yeah, people tell me all the time that they saw me in a video, but it is true. I mean, the promise of medical isotopes and what they could mean for Canada, both for health and for economic benefit, is really important. And we're hoping that our Strategic Innovation Fund proposal will be finalized in the coming weeks.
Yeah, it really is impactful, because I was at a Movember event last year, and there was an individual from Australia that was live streamed across there, and he was talking about it was a Canadian isotope that would be used for his prostate cancer treatment. So it really is stretched around the world, what's happening. One other question I wanted to ask you is, and I'm sure this has come up in conversations through the years, does Canada need to look at the way we do our accredited investor? Do we need to look at different ways so that people who maybe don't have the means of income or total investment dollars, that they could still participate in some of the venture capital projects, early stage funding rounds that maybe that isn't available to them because they aren't accredited investors?
I think that's a really good question. I think, part of the rationale behind accredited investors is that they're investors that have a lot of investment experience or a lot of capital, so that it's not, jeopardizing their retirement savings to participate in an investment. So I think we do have to continue to find that balance of, coming out with the right endpoints. But I think having a fund that would perhaps have professional managers, but who understood the space, but could deploy other types of capital into the system. I think that's a really exciting idea, and we're starting to see a little bit of it with more specialized funds being developed. There's certainly much more of that in the United States, but I think exploring, how we could bring that in a sort of a targeted or focused way to Canada, I think is a really exciting idea.
Dr. Singh, I was just wondering with you out in Saskatchewan, what are some areas that are chronically underfunded that are great ideas at the university, say specifically in agriculture, but just always seem to come up short in funding? What is there any out there that you can identify or?
I mean, I couldn't put my finger on any specific piece, but overall, there is a feeling that in Canada, we have underfunding of our research system and also underfunding of the connections between the basic science and the applications for commercialization. For example, to add to what has been said about Triumph, University of Saskatchewan has a cyclotron. We produce isotope, contributing to the Canada's capacity as one of the major countries to produce radioisotopes. And we also have Canada's only Canadian light source synchrotron, which is situated at the University of Saskatchewan. So when you look at the discovery science and the papers which are coming out, I think the connecting piece is not as robustly funded and it's not as robustly connected. There might be a suite of programs at the provincial level, at the federal level. Those are not deeply connected with each other. And last point I would make is I think there's a need for the universities to directly have a fund at their disposal where they can provide it to the inventors at a very early stage when they find something truly interesting. The reason I'm asking for that is when an inventor discovers something, it takes a long period of time to get the funding to move it to a TRL level 1, 2, 3. If the universities had a purse of money, they could quickly invest in that product. And while we are looking for additional funding or creating connections with the private sector. So those are a couple of ideas which I would like to submit.
Merci, député Loeb. Le temps de...
Thank you, Mr. Loeb. Your time is up. With 5 minutes rounds, we're going to Mr. Lauzon. Well, thank you, Mr. Chair, and congratulations on your good work replacing the other deputy chair. I'd like to start with Mr. Singh. You talked about commercialization and intellectual property as it relates to small and medium-sized businesses, and that's what I'm really interested in rural areas. There are many small businesses. And I'd like to know how those small and medium-sized companies could work more directly with the universities. Because in the isolated regions, we don't have CEGEPs, Quebec colleges, universities, and we have to look to equipment providers who are the ones doing research for us. But how could these small companies, which have intellectual property, because they've gone from small companies to up to 100, who've developed products that you don't even know about, how can we improve that relationship between those who are outside of the system, and how can we link them to the universities?
Thank you very much. I think that question is of deep importance to our country, as large as our country is, with only 37 million people, and we are spread across a large landmass. The role of the polytechnics, for example, there is a very critical role when it comes to working with the small and medium-scale businesses, whether they are in the city or they are at a remote location. When I was making my submission about the disconnected or the better ways to connect our system, again, I was thinking about the province of Saskatchewan with very few people spread out in large municipalities. How do we reach out to the inventors in the communities who may not have direct accessibility University to Saskatchewan Polytechnic or the University of Saskatchewan, for example. I think that again leads us to the idea of the role of the provincial and the federal entities to create that awareness, create the forum where the businesses located in the remote communities can come to the universities and polytechnics to refine the product, to add the last technical piece to the product, and really work with the universities incubators to take their product to the market. University of Saskatchewan, fulfilling that need, just created an incubator house, which is very busy. For the last 12 months, we have dozens of teams who are learning from the incubator how to pitch their product, how to create the product, and how to move it to the market. So I think it's an ongoing effort, but we will win this game if we can create better connectivity between the federal and the provincial and the city levels of the government, and working with the universities and the polytechnics in this country, because isolation does not help us. So again, I look forward to the guidance from this committee and the government as to how we can support such a mechanism to connect with the sectors. I think I was giving an example of the farm train in the 20s from the University of Saskatchewan. Maybe we need to reinvent something like that through the modern ways of communication, the tele or the video conferences with our with such entities.
Vous avez créé un peu
We're talking about living laboratories in that sense, and we'll support you with that. Now, when we talk about research and recommendations, in fact, in your report that you sent in yesterday, you talked about the challenges with borders, national borders, and you proposed a mechanism that would be based on a change in culture. And I'm really intrigued by that. What kind of change in culture could be put in place to help with the commercialization of intellectual property?
Vous avez 50 secondes.
And we've only got 50 seconds.
Thank you very much. And one of the change in culture is the way we view intellectual property, the way we make investments. The recent investments in biomanufacturing hubs in our country is to really offset the challenge we felt during pandemic. We had no biomanufacturing capacity in our country. That's a national sovereignty issue. I think now working together with the universities and the private sector and bringing companies like Moderna into our country or Sanofi into our country, we can really have a mechanism to take the new vaccines, produce them in Canada, sell them around the globe, creating jobs and prosperity for our own people and protecting the health of animals and people in this country. Vaccine and Infectious Disease Organization at University of Saskatchewan has produced and marketed 6 or 7 vaccines, which are first of their own kind in the world. And so that is emerging as Canada's pandemic center. We are so thrilled to be partnering with 4 of the biomanufacturing hubs which are announced in our country. And again, I keep on requesting everyone, collaboration is the key for us if we are going to deliver on the promise that Canadians want from us.
Merci, député Lauzon.
Thank you, Mr. Lauzon. We now have the 2.5-minute round, and we'll go to Mr. Cannings.
Well, merci. I'm going to turn to Ms. Hayashi again. You brought up something during your introductory statements about the importance of the basic research, and Triumph is thought of as a very, very basic research. Looking at the basic particles that make up the universe. But you connected it with some very real developments and innovations, and I'm just wondering if you could expand on that. I think maybe I misunderstood you, but I thought you somehow connected dark matter research with COVID ventilators, and I'm not sure if I got that right, but maybe if you could expand on that in particular, because I'm very curious about it, but also the broader picture of how important it is to support and fund basic research to develop the IP that we're talking about here today.
It really is remarkable how those basic research ideas that seem very esoteric, like, oh, we're looking for neutrinos in a giant water tank in Japan. But we can take that detector technology that we use to keep the water clean in those giant tanks, and now we're turning our attention to, oh, well, could we make a clean water monitoring system that would ensure that remote communities and First Nations communities have clean water? So that's sort of a new idea that's come from a very basic research project. The COVID ventilators came from a lot of the equipment that has to be designed and built to do research into dark matter involves creating vacuums and valves and all of these sorts of technologies. And so when the Italians were literally dying because they didn't have enough ventilators, they asked just for help to work with them on creating a COVID designed ventilator. So all of our experts in gas movement and valves got together, worked with the Italians and the Americans, and very quickly designed, built, and then found a manufacturing partner and a funding partner in the government of Canada. So I think we started in March 2020, and by the fall of 2020 had delivered hundreds of ventilators to the government. But I think that was really when the light bulb came on of like, we can take these very brilliant people who have these the fundamental research technologies, but we can deploy them in new ways. For example, neutron detection. Apparently, neutron detection is something that's very important as a proof of concept for fusion energy. So we have a collaboration with a fusion energy company to help them determine whether their fusion energy technology is actually really working. We also do proton and neutron radiation testing so that companies like Cisco can ensure that their components will withstand radiation in the upper atmosphere or in space. So there's all of these things that we can use these fundamental technologies for. And I think the really exciting part is when we give our researchers funding and a bit of bandwidth to focus on more applied technologies, really exciting ideas can come. And that's something that we're going to be focusing on in the future. How do we get funding to allow these brilliant researchers some time, focused bandwidth, and some personnel to turn their mind to more applied problems?
Merci, député Cannings. Nous poursuivons maintenant.
Thank you, Mr. Cannings. Now for the 5-minute round, we've got Mr. Mazier.
Thank you, Chair. Dr. Singh, can you please table with the committee how much money your university has received from the federal government for research and how much your university has made for licensing of intellectual property over the last 5 years?
I will be happy to do that. We will submit it to the committee in the day.
And Ms. Hayashi, could you do the same?
Yes.
Thank you. And again, for the both of you, can you table this with this committee what percentage of your IP has been transferred to Canadian companies and non-Canadian companies over the last 5 years?
Okay.
You both do that? Dr. Singh, I'm very interested. I've been from the farm all my life. I'm very interested in the agriculture development, especially when it comes to seed production. And you suggested, or you talked about never too early as far as getting involved in IP protection. I think if I'm hearing you right in your testimony and in your comments, we need to have a different approach when it comes to IP protection, or at least getting the value of IP in Canada here. And I'm wondering if you can expand on that a little bit more. Like right now, we've got a system that we're still very focused on the jobs part of it, or the people actually putting people in big plants and stuff like that. But there's the intangible, the non-tangible kind of assets that are out there right now are proving to be greater value in the intellectual property that is, I think, Canada is really falling short on. So I don't know if you could expand on that, or if you could comment on that maybe we need to have a different look on how we protect intellectual property in Canada here.
Thank you very much. May I request you to speak to one or two intangibles that you think we need to look at, as you mentioned?
What are the intangibles?
Yeah, you're mentioning that there are some intangibles that we need to keep in mind when we look at intellectual property?
Well, everything from the information, even what we learn here in
Right.
Canada, and then you give that information back to the seed developer in agriculture's point of view. Yeah.
Thank you very much. I think the intellectual property piece is, as I said, is always under flux with the new legislations and the legalities around it. But at the same point, our ability to identify a piece of knowledge that could have a material effect on the prosperity of the Canadians, whether it's a job creation, for example, or it's protecting the health of the animals and the humans in this country, or it is by creating the royalties with the products which might be produced some other jurisdiction to bring back to us. Sometimes I believe that an intellectual property piece, it could also advance Canada's diplomacy around the globe in countries where there's a food security challenge, water security challenge. May I give you an example? The discovery of the virus that I was referring to at the University of Saskatchewan, which affects the pigs, is called sarcovirus. Few years later, we figured out that this virus is actually causing a disease in the pigs. And once we developed the technology to produce the vaccine, it was purchased by a company which is based in France. But still, through the production of that vaccine, not only we protected the health of the pigs in this country, which is a multi-billion-dollar export, we also were able to generate about $100 million in royalties to the inventors, to the university, to further plow back into the research ecosystem. So I really agree with you.
Would you use royalties in same type as intellectual property then? Is that how are you viewing that when you talk about royalties?
Yes, I'm talking about royalties as a benefit out of the intellectual property as one of the benefits when we create a protection on a piece of knowledge. Sometimes when we are working with the producers to solve a problem on the farm, we may just generate the knowledge, give it openly, not create a patent on that so that it's available to the Canadian farmers without any worry about the use of that piece of knowledge.
And I guess what I'm wondering is maybe we should. There's good support for universities as far as innovation and invention, but not much on economic development. Like, how do we hang on to that intellectual property? And Ms. Hayashi, I don't know if you have anything to add to that.
I mean, I think that there's almost a feeling that once you patent something, it's ready to go. And there's so much more to making something commercially successful than simply filing a patent. And I think that's exactly what you're talking about. We really need to find those resources to put people on projects to accelerate them. I mean, most researchers don't have the skills or expertise to immediately start a successful company. So how do we connect them with the right people to add to the team to advance that technology? And that's the space that Triumph Innovations is in, providing business development support, providing the people that are going to figure out what companies are in this space and call them or receive calls from companies that are interested in working with Triumph, and then working to kind of translate that. I think this is what Dr. Singh was talking about. In culture change, the academic culture and what academic researchers focus on is quite different.
Excuse me, I have to interrupt you. The time is up. We'll now go to the 5-minute round to MP Bradford.
Merci, Monsieur President. To our witnesses, and please excuse my laryngitis voice today. I'm sorry, I know it's very annoying. Ms. Hayashi, you made reference to the Creative Destruction Lab. It seems a bit of an oxymoron. Can you just elaborate what goes on there, what kind of things you're creatively destructing? And since none of us have had a chance, well, at least I haven't had a chance to see this.
So it's a really remarkable program that started off in Vancouver and then sort of went viral. So now that there's Creative Destruction Lab Rockies, there's Maritimes, there's subsections for health sciences and space and quantum. So I think the idea obviously has a lot of interest and momentum behind it, but basically it gathers together mentor investors, and this is a real key. When we sent our startup company into Creative Destruction Lab, they're like, "Oh, I don't really want to go into another accelerator where somebody tells me how to write my business plan one more time." And I said, "No, the difference is that the people involved in this are investors, and after every round." There's a question asked to the investors at the table: is anyone still interested? How many people are still interested in working with this company and potentially investing in this company? And if nobody puts up their hand, the company is exited. So it really forces people to be looking at real tangible things, not theoretical things like, oh, does somebody want to invest in the company? No. Do I want to invest in the company? Does my colleague want to invest in the company? And so we've seen a lot of investment come, and a lot of the companies really being incented to make the milestone or do the work to get to the next meeting, because they know that investment dollars are literally at the table and they're speaking to the investors. So I think it's a really interesting model, and I would encourage you to take a look. And I'm sure we could get you invited to the UBC one if you like, but there's other ones across the country that are. It's a really interesting and successful piece. I mean, we've made excellent contacts that have helped us not with one technology, but now we're looking at new technologies, and the contacts that we've made there are helping us with, oh, you should talk to so-and-so. If this is a mining technology, let me introduce you to somebody. It's really a wonderful networking.
So it's more like a pitch program. Like we have some hubs and things like that here in Ontario, and it sounds like it's kind of like pitching and trying to connect with investors and partners.
It is a pitch program. I think the subtle difference is that the investors are there to invest in those technologies. And the idea is that by the end of the program, some of them will have invested in the technologies that have been successfully advanced through the program.
Okay, great. Next question is for Dr. Singh. National security and patents transferred to foreign countries has been raised previously. Under the Investment Canada Act, investments from foreign investors are subject to ICA review, including sensitive sectors which receive enhanced scrutiny. Our government's introduced Bill C-34, which updates the national security review process of the ICA, including a new requirement for pre-implementation filing, which would seek to prevent the transfer of IP and other sensitive information before a review is completed. This would prevent the company from closing its transaction before the review is completed, therefore stopping the transfer of sensitive IP and other sensitive info. Can you comment on the importance of this sort of review?
We continue to work with the federal government, and any directions on the security of our research and the knowledge we create and the knowledge we mobilize to any particular entity. The guidance and the advice from the federal government is always sought. And this is I would say this is a very new landscape for the universities. We are learning how to do better and also to comply with all the new requirements which are coming through. And there's quite a bit of conversation on that. What we need to figure out within that space is how we do not lose time and our ability and the speed. When we have something very sensitive, we need to mobilize somewhere. I think we are at an early stage of this particular new environment of the national security and the security of our research enterprise, looking after 3 or 4 major research facilities at University of Saskatchewan, from vaccine to synchrotron to a nuclear cyclotron. We continue to work together with the federal government. But again, I will submit the speed is the key. We need to find a way that we do not slow things down any further than where we are.
Okay, thank you so much for that feedback. That's all the questions and all the voice I have. Thank you.
Merci, Député Bradford.
Thank you, Ms. Bradford. That brings to a close the question period. I'd like to thank our witnesses for joining us in the second hour of our meeting. Ms. Yashi, Mr. Singh, thank you for your comments, and you're now welcome to leave the meeting.
Thank you so very much for this privilege.
Thank you very much.
Collègues, avant de
Colleagues, before we wrap up today's meeting, last week the clerk had distributed a draft budget for our study on the support for the commercialization of intellectual property. Are there any questions, or can we make a motion to adopt the budget? I move the adoption of the budget. Anybody seconding? The budget is adopted then, unanimously. Good. Now, before leaving, I would like colleagues to inform you that we received a written answer from Mr. Champagne from his appearance on February 2nd. It has been distributed to committee members internally. We'd like to know if you agree, if there's a consent for it to be added to the internet site, the committee's internet site. Inaudible.
Oui. Il a été distribué pendant la...
It was distributed during the meeting. During today's meeting? Oh, I haven't looked at it. I think we should familiarize ourselves with this and discuss that at the next meeting.
C'est l'accord du comité, donc.
That's the will of the committee then. Thank you, Mr. Soroka. Then that concludes this part of the meeting. Our next meeting is on March 23rd. The notice will be published soon. Does the committee wish to adjourn the meeting? Ms. Diab? The committee stands adjourned.